In this section, we'd like to write down the equation of motions in a rotating systems. As I explained, object with the masses of the m sub 1 and m sub 2 making the circular motions around the center of mass. So two objects with m sub 1 and m sub 2 is on the x-axis. XY frames is rotating with respect to the Gaussian and I.4.4 inertial frames. So coordinate of the m sub 2 is expressed m sub 1 over m sub 1 plus m sub 2 times r sub 1 2, and the y coordinate is 0 and the z coordinate is 0. And the location of the object with the mass of the m sub 1 is x coordinate is negative m sub 2 over m sub 1 plus m sub 2 times r sub 1 2. And the y coordinate is 0, z coordinate is 0. So in the rotating frame, the position of two objects are fixed. So it's quite easy to consider the motion of the object with mass m in the rotating frames. So relation between the inertial and the rotating frame can be expressed this equation. We have studied the rotation matrix before. So if you have difficulties, you can review the rotation matrix. So equation Gaussian I.4.4 inertial frame and the XY frames has a relation with the angle of the rotation matrix for thetas. When we study the rotation matrix, this corresponds to thetas. And then in this case is the rotation angle of expressed omega t. So Gaussian is equal x cosine omega t minus y sine omega t. I.4.4 is x sine omega t plus y cosine omega t. Theta equals z. And also we can express the x, y, z as a function of the Gaussian I.4.4 thetas. So we can use the original equations by converting. Omega is minus omega, and the x is the Gaussian, and the y is I.4.4, and the z is thetas. In this system, we consider the Gaussian I.4.4 frame is rotating, opposite direction of the rotation of the minus omegas. Then instead we convert x, y, z, and then opposite direction of the rotation in the opposite directions. Then we can easily derive another equation. Okay. Then velocity and acceleration. From this equation, Gaussian is related x, y, function of the cosine omega, and the sine omega t is a function of t. So we have a Gaussian equal x cosine omega t minus y sine omega t. Derivative of Gaussian with respect to times is expressed x dot cosine omega t minus x omega sine omega t. So derivative of the first term produces the two terms minus y dot sine omega t minus y omega cosine omega t. So from these equations, you can find that x dot minus omega y cosine omega t minus y dot plus omega x sine omega t. The second derivative is more complicated, but you can keep calculating, and finally you will get the accelerations. So velocity is the first derivative with respect to times, and the acceleration second derivatives. Then equation motion, inertial frames. This is the equation of the motion of the inertial frames. And let's just substitute the accelerations. For example, second derivative of the g with respect to times is expressed. This is correspond to the second derivative. And this is correspond to the second derivative. And also the g, this part is changing. X cosine omega t minus y sine omega t. Okay, so it appears here. And y sine omega t. Because y sub 1, y sub 2 equals 0. This is the equation 1. This is the equation 2. Equation 1 times cosine omega t plus equation 2 times sine omega t. You can get the first equations. So if you look at this equation, if you multiply the cosine omega t to the first equation, and this second equation sine omega t, cosine square plus sine square equal 1. Then you have only the this terms. And the second term is going to be cancelled out. And then you will get the first equation. For the second equations, if you calculate first equation times minus sine omega t plus second equations times cosine omega t. You can calculate this one, and then you will get the second equation. y2 dot plus 2 omega x dot minus omega square y. Second terms on the left hand side we call this is the Coriolis force. And the third term in the left hand side we call the centrifugal force. So it might be better to write the equation in this way: x2 dot 2 omega y dot plus omega square x minus g m sub 1 over r sub 1 cube x minus x sub 1 minus g m sub 2 over r sub 2 cube x minus x sub 2, and the y2 dot equal minus 2 omega x dot plus omega square y minus gm sub 1 over r sub 1 cube plus gm sub 2 r sub 2 cube y. It is better to use this equation to find the direction of Coriolis and centrifugal force. So this first term on the right, this is a Coriolis. And the second terms on the right is a centrifugal force. If the object with mass of m is moving to the downward, this direction, then this means y dot is negative, x dot is 0. Then Coriolis force. This is the Coriolis force. X dot is 0. Coriolis force in the y direction is 0. Y dot is negative. So this means Coriolis force on the x direction is negative. So this means Coriolis force is directed in the negative direction. This is the direction of the Coriolis force. The centrifugal force is directed outward direction. Okay, this is centrifugal force. Is omega square x and omega square y. Okay, so directed outward direction. Centrifugal force. So centrifugal force is quite easy. You can connect with this point, and centrifugal force is directed outward. So in this situation, x dot is 0. Y dot is a positive quantity. So again, x dot Coriolis force on the y direction is 0. Coriolis force on the x direction is a y dot is a positive. So Coriolis force is a positive direction. So this is a Coriolis force. Okay, so we could find that Coriolis force. Also another case. At first it's better to considering the centrifugal force. You can connect with the origin to the object. So centrifugal force is this direction. Centrifugal force. Centrifugal force. And the Coriolis force. So in this case, x dot is negative. Y dot equals 0. So go back to the distance. Y dot equals 0. Coriolis force on the x direction is 0 because the y dot is 0. X dot is negative. So Coriolis force should be the positive direction. So Coriolis force is directed upward. Coriolis force. So for in this position, y dot is 0. X dot is positive. Then Coriolis force is directed downward. So if you combine all the direction, when the particle is moving to the right direction, Coriolis force is acting downward. When the particle is moving to the downward direction, Coriolis force acting on a negative direction. When the particle is moving to this place, Coriolis force acting. Particle is moving. So this is a V, B, B, B. Coriolis force directed. So this is the Coriolis force. Coriolis force. So direction of the cyclone in the northern hemisphere is the anticyclone motion. Okay, this is the direction of the motion. So we can understand the direction of the cyclone by considering the Coriolis force. So no work done by the Coriolis force because the Coriolis force is always perpendicular to the direction of motion.